Hey Thinksters, and welcome to this video. It's Chris, founder of Thinkster.com. So in today's video you're going to learn how to analyze the Instagram social network in a single line of code using only Python's NumPy library for data science computation. And this is part of my one-liner book series. My new book, Python One-Liners, just came out with no starch press, and it consists of 5 chapters. 5 technical chapters, and in each chapter we are addressing a different area in computer science. Like in this current series we are addressing the data science chapter, and we have 10 one-liners in the area of data science, and particularly in the area of the NumPy library. And the NumPy library is like the basis of everything in data science and machine learning. For example, if you want to become a machine learning engineer, you need to know about TensorFlow or scikit-learn. But all of those libraries build on NumPy. Even if you want to go more into the area of data science, data visualization with matplotlib, or with like maths, or even pandas library to do web scraping libraries, all of those libraries, they build on NumPy. So NumPy is the foundation. So therefore I decided to include NumPy one-liners as well in the book. Okay, and so let's dive right into the code. Okay, so I have some old code here. Say you have the following data here. So let's reformat this data, make it a bit prettier. Okay, you can already have a look at the data. It's a two-dimensional matrix of popular Instagram accounts. Okay. And so we create a NumPy array out of our list of lists. And I missed one entry here. Okay, so we have basically 2 values in each list. So in each row, we have like 6 rows and 2 columns. And the first column is the number of followers in million of some Instagram users. And the second one is like their identifier. Okay, so for example, at Instagram themselves, they have 232 million followers at this point, probably more in the meantime. Selena Gomez has 133 million, Victoria's Secret 59 million, and so on. Okay, so we have some popular Instagram accounts, and now we want to use NumPy to find the names of the Instagram superstars with more than 1 million followers. Okay, so there are some followers like here Instagram, Selena Gomez or Cristiano Ronaldo, who have more than 100 million followers, but then there are also some Instagram influencers like Victoria's Secret who have less than 100 million followers. And now we want to get the names. We only want to get the names. We don't care about the the millions of followers. We just want to have a list of names. Say you are an advertising company and you want to contact all the like high threshold influencers. So you just want to have their names, and then send a standard request Instagram message to them. Okay, so it has some applicability, but yeah, let's dive right into the one-liner. So if you want, you can pause the video now, come up with your own one-liner or multiple-liner solution, and yeah, compare it with the one I give here. Okay, so it's a quite simple one-liner if you know about different NumPy features like Boolean indexing, for example. So we create a variable called superstars, and we just store our superstars in this variable. Okay, and so if we print superstars, we want to have the result like a list of superstars: Instagram, Selena Gomez, Cristiano Ronaldo, and Beyonce. I don't know how it is pronounced. Okay, like this. And yeah, how do we get this? Basically, we use simple indexing with a square bracket notation to index a subset of those people. Okay, of this NumPy array. So inst, this inst, is the variable name of a NumPy array, so we can use advanced indexing to access some values. Now we have to decide which values we want to access. Okay, so we already know, like now simple NumPy indexing, you can use rows and column indices to index data in your NumPy array. And we already know like columns, which columns do we want to index? Yeah, we want to index like the column with index 1. Yeah, why? Yeah, because the first one, like this one has this column with the first column with index 0 gives us just a numerical value of the number of followers of those people, of those influencers. But we don't want to have those. We want to have the names of the followers. Okay, so and therefore we need to access the column with the index 1. So this is already clear. Okay, now we simply need to get the rows of the people with more than 100 million followers. How do we do this? If you want, again, you can pause now and try to figure it out. Try to get the row identifiers of the influencers with more than 100 million followers. Okay, so it's basically the first step is to figure out the rows is to access all rows. Okay, now this one, now we have like this nested indexing scheme. This part gives us all like all the in a one-dimensional NumPy array. It gives us all followers. Okay, so it gives us just these numbers. It gives us like the first column and all rows. We use simple slicing to access all rows, and we only want to have the first column of these numerical values. Okay, now we have all the numerical values. Now the problem is basically, let's don't focus on this problem. I will give it in a moment. Okay, so now we want to have, so we have all these numerical values and we want to check whether they are larger than 100. It's as simple. Okay, this is called simple broadcasting, and you have learned about this in the last videos if you watched this series in the sequence. Broadcasting means that, yeah, we have arithmetic operations or even Boolean operations, logical operations, where we have on the one side a NumPy array with some shape, and on the other side we have another NumPy array or even a numerical value with a different shape. And broadcasting now tries to like increase the, or try to make the shapes of both operands equal. Okay, so it tries to assimilate the shape. So how does it do it? Yeah, it takes the one with the less complicated shape, I'd say, and simply copy paste this value to the more complicated shape. Okay, so if we have a one-dimensional NumPy array like here, it will simply create a one-dimensional NumPy array out of this numerical value 100. So now you have a NumPy array of multiple values conceptually of multiple 100 values. Okay, so like 100, 100, 100, 100, so that both shapes are equal. And now we perform this element-wise comparison operator. Yeah, so we check for each element in our NumPy array, in our one-dimensional NumPy array, we check whether it is larger than 100. And this gives us an array of truth values, either true or false. Okay, so now we have a NumPy array of truth values, and our result will be true if this integer value is larger than 100, and it's false if the integer value is smaller than 100. Okay, and so we have like either true or false values, and yeah, we have the value true if our Instagram influencer has more than 100 million followers. Okay, and now we use this Boolean array to access the rows for which we have a true value. Okay, with a because I mean we will have like value the NumPy array true, true, false, true, true, false, and this is exactly what we want. And now we can use this Boolean. We can use this as Boolean indexing. So rather than giving here a specific indices, we can also give like a sequence of truth values, and so on. Yeah, so you can also like index certain elements just by giving a sequence of truth values, and this is what we are doing here. Now we are giving the, let's go back, we are giving the first argument, the rows we want to have. We do not specify them with slicing, we specify them explicitly with our NumPy array of truth values. Okay, and we access only the rows for which the first numerical value is larger than 100 basically. Okay, so that's it. But then there's one small detail, and this is that, like, if you would execute this code, this probably leads to an error. So if you run it, yeah, this larger than operator is not supported between instances of NumPy and the array and integer. So what is the problem now? The problem is that this NumPy array, so NumPy array can have only one data type. The whole NumPy array has one data type. And if there are like multiple data types in the NumPy array like this, then it still works, but then the array data type will be object, because object is like the lowest common denominator, if you want, between those objects. Yeah, you have an integer and you have a string value. I mean, there's nothing common of those. So the only common thing is that they are both objects, basically. So NumPy creates an array of objects, not an array of integers or so. But here, this comparison operator requires that we have a numerical data here. Okay, so therefore you need to like convert this as type float. So you can use this NumPy array function astype and give the data type, and then you convert this one-dimensional array of type object, if you want, to a type float. Okay, and now it should work. If you execute this, you get all influencers with more than 100 million followers. Okay, so this is Instagram, Selena Gomez, Cristiano Ronaldo, and Beyoncé. Okay, so that's it. Very concise one-liner solution. So many people would use multiple lines of code. So even if you are a beginner, probably you would have used multiple lines of code. But advanced NumPy experts, they use only a single line of code for these types of problems. And if you have seen many of those examples, for example, if you solve Python puzzles at my app Thinkster.com, I also have a lot of NumPy puzzles. If you solve these puzzles repeatedly again and again and again, then at one point you will become very proficient in the use of those tricks, and you will do it like while you sleep. Okay, so check out the book, Python One-Liners. Check out my other book, Coffee Break NumPy, which will also give you a lot of puzzles and train your skills here. And yeah, thanks for watching this video, and see you in the next video of this series. Bye.